Hello, and welcome to tutoring. Today we're going to talk about balancing equations. Alright, so for balancing equations, we have the reactant side and the product side, right? So these A and B would be the reactants when they're on this side, and AB would be the product on this side. So when we're balancing equations, we want to make sure that they're the same number of A on the reactant side and the same number of A on the product side. And the same goes for B. When we're trying to balance an equation, when it's not balanced, the only things that we can change are to put numbers in these spaces, right? So numbers can go here, here, and here. We're not allowed to put subscripts, add subscripts here, 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 or here, right? We can only put it here in front. So with that, let's try an example. Alright, so we have that the 4 atoms of phosphorus plus 2 chlorine atoms yields 1 phosphorus atom combined with 3 chlorine atoms. Okay, so we're going to begin by counting the phosphorus on the reactant side. So we know that if we have a subscript here, that tells us that there are 4 phosphorus atoms on the reactant side. If we do it for chlorine, we see that we have 2. Right? So this is just basically saying that we have this plus this, and they're together, right? And we write a shorter way by just putting the chlorine symbol and a subscript of 2. Now for the products here, we do the same thing. So we count the number of P atoms, and we have 1, right? The 3 here only applies to chlorine here. So the subscript directly after an element will tell you how many of that element you have, as long as space here is empty, and when it's empty, you know it's 1. So for chlorine, we have 3. So looking at both sides, we compare. So there are 4 over here, and there's 1 over here. There's 2 chlorines here, and 3 over here. So here, knowing that whatever we put here will multiply each element by that number, the subscript will be multiplied. What times 1, right, will give us 4. So we know that 1 times 4 is going to be 4. So we can try to add 4 here. So that changes the number of phosphorus. So that changes to 4. And now we also have to multiply 4 times 3, which we know is 12. So now the phosphorus atoms are matched up on the reactant side and the product side, but now the chlorines still have to be balanced. So we have 2 over here, and we have 12 here. So what we do is ask ourselves, what number would go here that would tell us that we have 12 chlorine atoms. We already have 2 here, right? So what number times 2 will give us 12? So that would be 6. Right? So 2 times 6 is 12. So now we know that there are 4 phosphorus atoms here, and 4 over here, 12 chlorines here, and 12 here, right? So 4 times 3 in this case for chlorine, and 6 times 2 for chlorine here, which both gives us 12. So for our second example, so now we have aluminum plus oxygen gas yielding aluminum oxide. Okay, so now same rules apply. We can only put numbers here, which would multiply whatever subscript is here. So when there's no subscript, just to make it clear, right, there's nothing here, that just means that there's 1. Okay, so let's count again. For aluminum, we have 1 on the reactant side. For oxygen, we have 2, right, subscript here. And then for the product side, we have 2 aluminums because the subscript here is directly after the aluminum, so we know it applies here. And for oxygen, remember, when there's nothing here, it's 1. Right, and there's nothing here to multiply by. So nothing indicates 1. Alright, so let's see here. We have 1 aluminum here, and 2 here, 2 oxygens here, and 1 oxygen on the product side. So clearly it's not balanced yet. So what can we do here? I encourage you to pause the video and see if you can figure it out. Alright, so here, right, we only can add numbers here. So what times 1 will give us 2 for this side? So we know that 2 times 1 is 2, right? So we can put a 2 here. So now our new number of aluminums is 2. Now for oxygen here, we have, we can use the same logic, right? So 1 times 2 is 2 for oxygen. But when we put the coefficient here, it applies to aluminum and it also applies to oxygen. So we know that it's 2 times 1 for oxygen, which gave us 2 oxygens. So oxygen is fine for now. But for aluminum, it has to go 2 times the 2 here, which we know that 2 times 2 is 4. So our number of aluminums changed to 4. Okay, which now, when we look at the aluminum number on the reactant side, we see that we only have 2 compared to 4. So what times 2 is 4? So we know that 2 times 2 is 4. So the 4, right, would go right here. Right? So in the end, the balanced equation would be 4 aluminums plus the 2 oxygens, which would yield the 2 aluminum oxides. Okay, and you can double check, right? So you have 4 aluminums here, and you have 4 here, right? 2 times 2. And for oxygen, you have 2 here, given by the subscript, and you have 2 oxygens here when you multiply 2 times 1, right? There's the little imaginary 1 there. Alright, for our final example, so example 3, alright, so the same process will apply here. We count the number of carbons, count the number of hydrogens, and we count the number of oxygens. Right, so what is the number of carbon on the reactant side? It would be 5, right? The 5 subscript tells us that. Now for hydrogen, we have 12, right? Remember that here, when there's nothing, it indicates 1. So 12 times 1 is 12 for hydrogen. And for oxygen here, we have 2. Right, 2 times 1. So now, over here, we have 1 carbon, right? There's no subscript directly after the carbon, so we know it's 1 times 1, which is 1. Then we have hydrogen, which is 2, so we have 2 hydrogens. And for oxygen, right, we have some oxygen here. We have 2 here, plus 1 over here. So we add them up to find the total number of oxygens on the product side. Alright, so looking here, we have some differences that we have to match up. So here for carbon, as a general rule, you want to balance the elements that appear only once on each side of the equation first before you tackle the elements that appear more than once. So carbon only appears once on each side, once here, right? Carbon here, and carbon here. For oxygen, it appears more than once. Here it appears only once, that's nice, but over here, it appears here and here, so it appears twice on the product side. So knowing that carbon only appears once on each side, we can figure out the carbon first. So 1 times what would give you 5? So 1 times 5, right, would give you 5. So here, now that we put the 5 here, we have to multiply 5 times 1 carbon. So 5 times 1 is 5. And we also have to apply it to the oxygen, right? So the 5 applies to the carbon here, and also applies to the oxygen here. So when we apply it 5 times 2, we have 10 oxygens. So oxygen is 10, and then remember we have 1 over here too, so plus 1, which is 11 oxygens so far. Okay, so now moving on, we can see hydrogen only appears once on each side, once here, doesn't appear here, doesn't appear here, and appears here. So we can tackle that next. So what times 2 is 12? So it would be 6, right? So we multiply here and give us 12 hydrogens. So we know that the 6 has to go here. Alright, so because the 6 is in front of the hydrogen and the oxygen, we know it applies to the hydrogen, which we already calculated right here, and it also applies to the oxygen. So now we have to recount our oxygens on the product side. So we have 6 here, right? 6, so 6 times 1, right? There's imaginary 1 here. Plus, remember we have some oxygen here. So 5 times 2, we knew from our previous count that it was 10. So now 6 plus 10 is 16. Alright, so far we have 5 carbons on each side, 12 hydrogens on each side, but our oxygen count is different. We have 2 over here and 16 over here. So what times 2, we can call it x, will give you 16. So we know that if we put an 8 here, then we'll get 16. So we can put an 8 here. Now our number of oxygens on each side, on both the reactant and the product side, is the same, right? We have 16 here and 16 over here. So now the balanced reaction, just so you can see it a bit more clearly, would be and this would be an oxygen here, not an 80, and that would yield this. Okay, so that would be the final balanced reaction.